All right, welcome to the first episode of setting up a Sentinel node. So if you don't know anything about Sentinel, it's a decentralized VPN, so blockchain-based VPN service where anybody can host a node. And I want to set up a node on AWS. So today we're doing the first step, which is getting the AWS node ready so we can actually SSH into the node and then start setting up the whole thing. So for that, we go into the AWS management console and we're going to need to get to EC2. We're going to want to run up a node. And we're going to do several steps here. First, we're going to look into which machine do I actually want to run it on. There I have two recommendations for you, and we're going to look at those. We're also going to look a bit at the pricing and figure out how much this will most likely cost us. And in the later videos of this tutorial, we're also going to check if our estimations are living up to our estimations. So if our budgeting that we estimated is actually true in the real world. So let's have a look at the AWS pricing things. So I think what could be a good pick for our machines, they recommend at least 2 cores and 4 gigabytes of RAM. So you could think that an A1 large is the best choice, but actually I looked a bit into it and there is the M5 large, which is, yes, it is more expensive. So with that price, if you look at that, that's gonna be $0.115 US per hour. We're going to do this 24 hours a day, and we're going to do this around 30 days a week. This already costs us $82. So you could say, yeah, okay, I want to save a bit, so I take an A1 medium, or basically an A1 large, which is already on about half of that, because it's a 0.0582 times 24 times 30. There we're going to end up with $42 a month just for running this EC2 instance. This is what we get with the large. So if you say, okay, I wanna test, this one is actually giving you 10 megabits of bandwidth. Let me find that. AWS EC2 search. They have a. Is it this one? No. I have to find it in AWS. Yeah, there we go. I think this is only prices. Yes, there were actually there is one thing where you can search for here, instance types. Details for instance types. So actually the A1 is actually interesting because the A1 large gives you up to 10 gigabits of network bandwidth. it would have, the large would have 2 cores, 4 gigabits of RAM, so that's basically exactly what we need. If we look here at the tutorial how to set this up, it says 2 cores, 4 gigabits of RAM, 20 gigabyte of storage or above. Regarding the storage, I'm gonna, for the tutorial's sake, set up the instance with an 8 gigabyte hard drive and then increase the size of that to 20. Because at a later stage, we're gonna set up alarms, for example, if the disk is running full or if the CPU is basically not enough to handle all the load, or if the RAM is not enough, so we can then on the fly update the machine and get notified by an alarm that our node has problems. We also gonna put in place health checks so that we get an email or an SMS immediately when the node goes down and stuff like that. So now we are at the hardware requirements. So here, this A1 large would give us up to 10 gigabits of network. That should be enough. But what I'm gonna go with is with an M5N large. So the N is for network. And that basically means this gives me 2 cores, 8 gigabytes of RAMs, only EBS, which is fine. In case we figure out that we need faster hard drive, we can also switch to the M5DN. The D is for... basically we can also hook this up to an NVMe SSD, which gives us faster throughput through the hard drive. So yeah, this is basically what I'm gonna go with, the M5N large. So I get 25 gigabit per second network bandwidth, and I'm gonna attach an NVMe SSD hard drive to that. If you want to go for something cheaper, the A1 large, where they have a spelling mistake here, haha, should also be enough. I think you need to have a lot of traffic to get at this 10 gigabit network bandwidth. I'll maybe downgrade the node at a later stage, but I also want to compare the two, how they actually, how they perform. If I can even test that with my crappy home location here, because I don't have 10 gigabit download at home. All right, that's that. So we looked at the numbers. I showed you how to calculate the costs. So the M5N large costs us approximately $100 US a month for hosting it. So let's get started. First, we want to launch an instance. We're going to take the Ubuntu server 20.4 LTS on an x86 infrastructure, because we need Ubuntu or higher for all the tutorials to run properly. I think it says it somewhere here that Ubuntu is needed. Probably, or maybe not for the node, because this runs Dockerized anyways, but at a later stage we also want to explain how to set up a Sentinel hub node. This needs a bit of a bigger machine than I'm just going to explain in the tutorial that we need a bigger one, but we're going to use the same image. And it said, I don't remember where I read it, but it definitely said that I need Ubuntu for this to run. So I can't find the info now, but let's not waste time on that. So yeah, we're going to take the Ubuntu 20 server 20 LTS. We're going to scroll down and take the M5N large, 2 cores, 8 gigabytes of RAM, 25 gigabit connection. Costs us $100 a month. Yes, let's do it. Let's review and launch. So yes, we have the SSH port open, so we can connect to it. This is almost everything not interesting to us. Storage is something important. At the moment we have an 8 GB size. If you say, no, I don't want to go through the pain and do the second step of the tutorial, you just enter 20 here, and then it's already gonna be increased. I'm not gonna encrypt the hard drive for now, because I would assume that my AWS is quite secure. I might change my opinion on that in the future once I set up a node for live. But now for the testnet purposes, let's just stick with this. So I leave that at 8, so I have the second tutorial step. And there we go. Let's launch the instance. I'm also gonna take another pair. So I'm gonna show you how you can create a key pair. We're gonna name this Sentinel test. This is what we're gonna use for all the tutorials. I have another live machine where I basically prepare for those tutorials, so I can tell you what to do. Then let's download the key pair. Yeah, we're gonna save this in here, and then we're gonna launch the instance. While the instance is booting up, we have to convert this key. I'm on a Windows machine. I assume you're doing this on a Windows as well. If you're on Linux, you can just use the SSH key as it is to SSH to the server. I assume you know what to do if you're using Ubuntu. I'm gonna do this on Windows. Just this is my work process at the moment. Leave me a comment if you want me to make a short tutorial on how to do this on subsystem for Linux, or which is an Ubuntu, so basically on Ubuntu. I can show you that as well. So we're gonna need a little software called Putty Gen. You can download this in the internet. I'll put a link to it in the description. Of course, all the links for all the other stuff, like the costs and the overview of the bandwidth for the AWS nodes, and other links that might be useful in the following time of this tutorial. So first we're gonna load this key file. Here we're gonna select all. This is gonna allow us to select the PEM file, and then we put a passphrase on it. I'm gonna do that outside of the screen. And then we're gonna save basically the private key. So actually now we can save the private key, and we're gonna save it at ppk, and we're gonna save it as Sentinel test. Let's double check in the folder. Sentinel test ppk, yes, it has been saved. Amazing. So then we can close the PuttyGen generator again. The node is already up and running. That's really nice. So we're gonna need the public IP to connect then in a second. Next we're gonna open Putty, but not the PuttyGen, but the Putty app. Here I basically have this already pre-configured. So this is gonna be the test node. What you need to configure is here. You have to enter the public IP. This actually, if you want to save money, you can shut down that instance, but to save money, because it's only costing you money when it's running. But when you boot it up, the public IP address changes. So every time you boot it up, like shut it down and boot it up again, you need to change that IP address here in your Putty. I'm gonna demonstrate this later again. Now we can actually save this test. So this is what we're running on at the moment. only other thing that you need to do in the settings is here what I usually do. I don't like to do stuff as the root user. So I set here in data the auto login username Ubuntu. That's just my default. You can choose whatever is to your liking. And when username is not specified, prompt. And then on SSH, you have to go to auth and basically do the settings like this. So here for an private key file for authentication, you browse and then select the right private key that you need, that you just created and converted to the PPK file. So once that is done, you can go back to the session, save it again, so it has all the changes, and then you can open the connection. You accept this server fingerprint, and then you enter the password for your key file, and ta-da, you have access to your node. So next thing I want to check with you is here. In this article, next thing we're going to do, we're going to upgrade the disk from 8 gigabytes to 20 gigabytes. So here I'm going to post you the link of this article as well. This explains everything. So this command here shows us what volumes are mounted. So we see here the dev root is an ext4 with, actually this only has 6.4 gigabyte. All the other stuff is used for other drives. And then to see the physical drives that are mounted, we're going to use the command lsblk. And here we can see the NVMe 0N1 is mounted with 8 gigabytes, and we want this one to be 20 gigabytes large. So we go back to our AWS console. And whoop, give me a second. And here we're going to see this bad boy is running. So what we want to do is now we're going to shut this down, stop instance. Every time you're not working on it and you don't want the nodes, let's say you are still in the process of setting this up, you can actually stop the instance to not waste any more money. So, okay, then of course our connection got closed. This makes sense, so we can close Putty because the server is not running, so we can't maintain an open SSH connection. And then once this is shut down, we can go down here, go to the volume, right-click it, modify volume, and increase the size to 20 gigabytes. Modify, yes, close. Let's refresh this so we can see that it's actually, wait, no? It says it's in use. Let's try this again. 20, modify. Are you sure you want? Might take some time. Okay, it's already in modification stage. Not where does it says that? It says in use. So we might just, yeah, see there, now it's 20 gigabytes. That's nice, so we can go back to our EC2. And also here it should already say, tada, here that instance, storage. Now it has a 20 gigabyte size volume. So that's nice. Then we can actually start the instance again. Now the machine is booting back up. And we can start Putty. We're going to connect with the test dVPN node. So we load this one and now see this IP address has changed to another one. This here ends on 18, that one ends on 40, so we want the new one. We don't have to save this because we're gonna shut it down and put it back up again. I know people who have burned fee credits on a weekend for not closing their Google Cloud instances. Yeah, not closing those instances can be expensive. Absolutely true. You can also set like a scheduled shutdown. So if you know I never work on those after 8 in the evening, you can configure them so they automatically shut down at a certain time. I'm actually wondering if I'm actually quite proficient with AWS, because I don't like AWS because it's so complicated, but I seem to have learned quite a lot of stuff about that over the years. Okay, anyhow, let's connect to this, accept the new fingerprint. Let's make this window the right size up here so you can see it, I can see it, everybody's happy. Enter the key, enter the password for the key. And now we can basically go through both commands again and see that here we now have 19 gigabytes available. So I thought this would be a bit more complicated because in the past you needed to increase the file system size when you changed the size of the physical hard drive, but it seems like AWS automated this process by now. So here we can also see the NVMe drive has 20 gigabytes now. So this was the thing for changing our machine. And that was it for today's video. So now we have a machine up and running that we can log into with SSH. And in the next video, we are going to continue with the tutorial where we're setting up a dVPN node. So, where is it? Can't find it. Here, host a node. This is what we're going to do, and we're not going to run it on Ethereum. We're going to run it on Tendermint because we want to prepare ourselves for the mainnet. And this is basically what we're going to start next time, because now we have an instance that is basically fulfills the hardware requirements. And then we can basically make the Docker container run. So thank you for watching. Leave the comments. If you have any questions, feel free to always drop by on my Twitch channel, Crusader W. Yeah. So hit the subscribe button. I mean, all the obvious things. It's obviously I have to tell this every video because research shows that people are just more likely to subscribe and support you if you tell them. And because, yeah, you can forget about this. So this was the first part, and next week we're gonna do the second part, or maybe even tomorrow. We'll see. And we're also gonna do the white paper review in the very near future of Sentinel. So thanks for watching, see you soon, and bye-bye.